structure is, what are the classifications of data structure, what linear data structure is, what non-linear data structure is, and what is the difference between linear data structure and non-linear data structure. And that is very, very important, very, very important, I have said. Now, today I will first discuss algorithm. Now, the name algorithm, you know the name. The name is very aware to you. That is algorithm. So I think all of you know what is the algorithm. So what is the algorithm? Basically, it's a process. It's a process by which we can solve a problem. It's a process by which we can solve a problem. Now, problem. What problem is? Problem is there in our domain. Problem is there in the Department of Civil also. Problem is there in the Department of Mechanical. You see everywhere. Everywhere. So what is the algorithm? The algorithm basically is to solve the procedure to solve the problem. Now, if we belongs to computer science department, then our definition will be something different. So what will be our definition? It's a sequence of instruction. Again, I am repeating. It's a sequence of instruction that takes some input, process those inputs, and produce some output. That is algorithm. No need to memorize. No need to memorize. Just think, you can answer anytime, anywhere. So what is the algorithm? It's a sequence of instruction that takes one or more input. So after taking the input, what it does? It processes those inputs, and after processing, it computes or it displays output. So that is algorithm. Now, there are no hard and fast rule. There is, how many times I will do? Now, there are no hard and fast rule to write algorithm. So you can write the function of the C code. That is also algorithm. You can write simply English-like language step by step. That is also algorithm. You can write the pseudocode also. Here, this part basically, it's a pseudocode. Pseudocode. See here, first step 1, input the first number as A. Here the problem is what? To check whether a number is even or odd. Very simple problem, and the algorithm is this. First you have to read the number, so that is your input. So after reading that number, you have to process. So here, what is the computation? You have to divide the number by 2, and if the remainder is 0, then you can say that it's even. Otherwise, you can say it's odd. So after that, in step 3, this is end. Here, so this is the sequence of instructions. Sequences are here: step 1, step 2, step 3. That takes some input, process those inputs, and produce some output. That is all about.
Sir,
Any question?
Priyanka Shah wants to join.
Hello,
Hello.
who gets noise?
Priyanka wants to join. Shayanto Saha.
Already I have joined.
Who the hell is
Hello, who gets it? Vivek Chauhan.
No one from our
Vivek
side.
Chauhan. What is
Sir, he's
this?
not from our class. He's not from
Not
our
of
Not of that.
Which one?
Joy Chakraborty.
Yes, sir.
All of you mute yourself. All of you.
Sir, Vivek Chauhan left the meeting, sir. Actually, he is playing. He is not in our class.
Oh,
Okay. And
so
one
Vivek
request for
Chauhan, he
sir.
is in which group?
Uh, we don't know, sir. Actually,
Actually, you don't know Vivek Chauhan, na?
no, sir.
Okay.
Oh, sir, there is one request for you. Sir, please turn off your camera. It consumes more data. Actually, you can see your screen. Actually,
Okay. That's why I want to hide the. Just a minute.
turn off your webcam, sir. Only. Thank you, sir.
Just a minute. Hide it. Now it's okay, na?
Yes,
Yes.
sir.
Okay.
Yes, sir.
Okay. So these are the steps, step 1, step 2, step 3, and so on. Now, what are the properties of algorithm? Okay, one thing that I would like to say, algorithm is language independent. What it means, for a particular problem, you have an algorithm. Now that algorithm can be implemented in any language. It may be implemented in C or C++ or Java and so on. So that's why we can say the algorithm is not language independent. Algorithm is language independent. And the third point here also, you can say algorithms are mainly used to achieve software reuse. Why? Once we have an idea or a blueprint of a solution, we can implement it in any high level language. That means your idea or your blueprint is same. That particular thing is basically the algorithm. Now, once you have an idea to solve the problem, that problem can be solved in any platform, any language. So that's why we can say this is nothing but the software reuse. Now, the properties of algorithm. This is also very important thing. What are the properties of algorithm? So there are several properties of algorithm. First one is input. So already I have said whenever I have given the definition of algorithm. So each and every algorithm, there must be one or more input. Similarly, the next property is output. For each and every algorithm produces some output. Number 3 is what? Finiteness. So what finiteness means? That means finite number of sequences, finite number of instructions are there in this algorithm. Finite number of instructions are there in this algorithm. So here it's a very simple problem, and the sequence of instructions is what? 1, 2, 3. Now, for a complex problem, there must be 1,000 lines of instruction. But the number of instruction definitely finite. There must be a finite number of instruction. There must be a finite number of instruction. The problem, the algorithm is maybe small, maybe large. Clear? Next one is definiteness. It means what? Each and every instruction is well defined. That means here step 1 is instruction. So what is the function of that instruction? The instruction has to read a number. That means the function of that instruction is well defined. That's why this is definiteness. And then the next one is order of sequence. So order of sequence means what? If I write step 2 first, then step 1, then step 2 has no meaning. Why? First we have to read a number, then we have to check whether the number is even or odd. Now, before reading a number, we cannot check. That means it maintains a sequence of it maintains an order of sequence. Is this clear? And the last one is correctness. Correctness means what? For each and every input, whatever be the input, the output will be, whatever be the input, it will get the desired output. Whatever be the input, for each and every different input, it will get different desired output. Different desired output. Is there anybody who wants to join? Let me check. Shubham Kumar Giri. It's now 3:11. So from the next time, I will not allow you. Okay, next.
Sir, can you explain the third point?
The third point is finiteness. Finiteness means what? Finite number. That means each and every algorithm, there must be finite number of instructions. Finite number of instructions. Here we have only 3 instructions. Suppose if there is a big, very complex problem, now for that complex problem, the algorithm may be 1,000 lines, but whatever it may be 5 lines, maybe 5 instructions, it may be 1,000 instructions, but the instructions are finite. Finite number of instructions are there for each and every algorithm. That is all about finiteness. Finite number of instructions are there.
Sir,
Yes, yes.
sir, third point, finiteness is included in properties of algorithm. Sir, why, sir? I want to ask: is there any situation in that case there may be some algorithm with no finiteness?
No finiteness. For no finiteness means infinite. Infinite number of sequence. No, not possible. Infinite number of instructions is not possible. Each and every algorithm, number of instruction, mind it, number of instruction must be finite. Finite number of instructions are there for each and every algorithm. The number may be 1,000, maybe 1 million, or maybe 5, but it should be finite number. It should be finite number. Yadav, Dhirendra Yadav, next time I will not allow you because you are already 15 minutes late. Okay. Next, I will discuss how we can analyze the algorithm. So basically, there are 2 ways. There are 2 ways by which we can analyze the algorithm. The first one is the time complexity, and second one is space complexity. Now, what time complexity is? What is time complexity? The time complexity is nothing but the time that an algorithm takes to execute. Is this clear? Time takes to a problem, or sorry, time takes to an algorithm to execute. That is time complexity. Now, basically, there are 3 types of time complexity. One is best case time complexity, one is average case time complexity, and another one is worst case time complexity. So what is worst case time complexity? Maximum time taken by an algorithm to execute. That is worst case time complexity. Now, whenever I have started the class, I have said how many students are there in this batch. So some of you have said 68. So if all the students wants to join here, I have to allow, or I have to accept, I have to press the accept button 68 times. So this is the worst case time complexity. It means maximum time that takes a algorithm to execute, or maximum time that takes a program to execute. This is worst case time complexity. Now I am giving you another real life example. Suppose I am giving you one assignment. Okay. So what will be the first question from your side? What will be the first question on your from your side? The question is, sir, what will be the time duration? कब ये submit करना है? Last date कितना है? What is the last date to submit the assignment? Everyone, we are all basically focusing on the last date. So that is all about worst case time complexity. Suppose I am giving you one assignment and I have said you have to submit the assignment within a week, or within 10 days. Okay, and most of the students, when I was student, I also did the same thing. Submit the assignment in the last date. That means this is what? This is worst case. So what is the best case? Today I am giving you the assignment and you can solve the assignment and submit it by today. So this is what? This is the minimum time. So best case means what? Minimum time to execute the program. Worst case means what? Maximum time to execute the program. And average case is what? In between, that is best in between minimum and maximum. That is average case average case time complexity. So each and every problem here we have to analyze the time complexity, and this is very important. You have to analyze the algorithm. Now there is another way by which also we can analyze the algorithm, that is space complexity. Now time complexity as well as space complexity, both are important, but time complexity is much more important than space complexity. Do you know what? If you open the book, if you open any book of data structure or algorithm, you can see that all the authors, they are basically focusing on time complexity rather than space complexity. Do you know what? Why? Because the price of CPU or processor is much more than the price of space or RAM. That's why our main objective is to reduce the time of an algorithm. Suppose I am giving you another example. Suppose sorting. So there are so many sorting algorithms. Bubble sort is there, selection sort is there, quick sort, merge sort, heap sort, and all. Now we will discuss why the time complexity of bubble sort is order of n square. Now what is order, what is n square, that also I will discuss today. The time complexity of selection sort is order of n square, but the time complexity of merge sort or quick sort is order of n log n. Now order of n log n is less than order of n square. N log n is less than n square. That means for sorting we have to use either merge sort or quick sort rather than bubble and selection sort, because the time complexity of bubble sort is order of n square. The time complexity of selection sort is order of n square, but the time complexity of quick sort and merge sort as well as heap sort is order of n log n. Clear? So in the next slide, okay. Now here for time complexity, our objective is not to determine the exact time. So exact time basically depend not only the algorithm but also the hardware. Suppose you have a Pentium 4 machine and you have a i7 or i9 machine, or you have a workstation. Now an algorithm that executes in Pentium 4 machine always takes much more time than that algorithm can execute in workstation or i7 machine. Clear? So that's why we will not bother here about exact time complexity. Here we basically represent time complexity as the function of input of an algorithm. And we basically use asymptotic notation. Second point here, asymptotic notation to define time complexity. So there are three types of notation. One is, there are three types of notation. One is known as big O. This is big O. Big O notation. Big OH, big O. Another one is big theta. Why I am saying big? Because little o, little omega, little theta is also there. So this is big O, here this is big theta, and here this is big omega. There are basically three notations. Sorry, this is big omega. OMEGA, big notation. Big omega. So these are the three basic notations by which we can represent the time complexity. We can represent the time complexity. And here the time complexity is what? It's a function of input, number of input of the program. Function of number of input of the program. Next, see here, efficiency. That is f of n, where n is the number of input of the program. Okay, now this is time complexity hierarchy. How many types of time complexity is there? Say first one is order of 1. You can say this is big O1, or you can say order of, things are same, ODER, order of, order ORDER, order of 1, or you can say big O1. Similarly, next one is order of log n. Next is order of log n to the power c, that is polylogarithmic time complexity. Previous one is the logarithmic time complexity. First one is the constant time. Last day I have discussed stack, and I have said the basic operations of stack is push a element into the stack or pop one element from the stack. Now for push a element into the stack, it takes constant time. Any multiplication, any addition, any subtraction, these are any expression computation of any expression basically takes order of 1 time. Next one is what? Order of log n. So this is smaller. Order of 1 is smaller. Now next order of log n. The time complexity of binary search is order of log n. I will discuss, I will derive how the time complexity of binary search is order of log n. No need to remember. I will discuss everything. Next, that is polylogarithmic. After that, linear time, order of n, it means linear. That means the time complexity is linearly dependent on the number of input. Here the time complexity is logarithm dependent on the logarithmic number of inputs. Now after linear, this is quadratic, that is order of n square. Then polynomial, order of n to the power c. And then last of all, that is exponential, that is order of c to the power n, or we can write order of 2 to the power n. So here the hierarchy is from minimum time to maximum time. Minimum time to maximum time. So order of 1, it means it's a constant time. Any constant time we can write is order of 1. Next, order of log n, that takes more time than constant. After that, polylogarithmic. After that, linear. So linear is greater than logarithmic, as well as it greater than polylogarithmic. After that, quadratic, that is order of n square, and obviously order of n square is greater than order of n, and so on. After that, polynomial, that is order of n to the power c, and the last one is exponential, that is order of c to the power n. Next, how we can calculate the time complexity if the algorithm is written in iterative way. First, consider this one. Consider this one. Here, what I have written, for I is equals to 0, I less than n. What is n here? N is the number of inputs. I plus plus, and within that I have written a single statement. That is, one statement block is there. Maybe it's a single statement or more than one statement. So how many times this statement will execute? Anybody? How many times? Exactly. N times. Exactly. N times. Okay. N times. That's why we can say f of n is equals to n, or order of n, or the time complexity is order of n. You can write order of n or big O of n. Now, when you will write big O, when you will write big theta or big omega, that I will discuss later. Clear? Why this is linear? Because the statement block maximum, the execution of the statement block is what? How many times? N times. Maximum n times the block will execute. That's why we can say this is order of n. Now come here. Come here. So it's a nested loop. For I is equals to 0, I less than n, I plus plus. Within that, you have another loop, that is for j is equals to 0, j less than n, j plus plus, and within that one statement block is present. One or multiple statement is there, or multiple block of statements is there. So what will be the time complexity here? It will be order of n square, quadratic. Why n square? Because when I is equals to 0, the whole block will be executed. Suppose here n is equals to 10. Suppose here n is equals to 10. Then when I is equals to 0, it will execute 10 times. When I is equals to 1, again it will execute 10 times. When I is equals to 2, again it will execute 10 times. It means it will execute 10 into 10, that is 10 square, that means 100 times. So if 10 is n, it will be order of n square. Is this clear? Is this clear?
Yes, sir.
Okay. Next one. Logarithmic loop. Here I have written one loop. For I is equals to 1, I less than 1000, and I is equals to I into 2. Now, someone please say how many times it will execute. So when I is equals to 1, it will execute. When I is equals to 2, when I is equals to 1, it comes here. Then the value of I will be changed to 2 into I. That means 2. So when 2, it will execute. After that, the value of I will be. After that, the value of I will be what?
4 and 8.
Exactly, not 3. It will be 4. After that, it will be 8. Next, it will be 16. Then it will be 32. Next, 64. Next, 128. So here this is 64, 128. Then what? 256, 256, and then 512. So how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. 10 times. So that's why we can say this is logarithmic loop. Here log 1000 base 2 is basically what? 9.96 approx we can say. Approx we can say this is 10. So here the time complexity is log n. Log n base 2. Again I am repeating, here the time complexity is log 1000 base 2. Here the time complexity is log n or log 1000 base 2. So how many times it will iterate? It will iterate maximum log n time. Maximum log n time. So same thing is true for division also. If I write I is equals to 1000, I greater than is equals to 1, and I is equals to I by 2, then also it will execute 10 times. So the time complexity is the function of time complexity is depend on the logarithmic of n, that will be log n. Next, suppose the loop is like this. For I is equals to 0, I less than 10, I plus, and within that j is equals to 1, j less than 100, j is equals to j into 2. J is equals to j into 2. One mistake is there here also. It will be I greater than, sorry, I less than 100, sorry, 1000. So I is equals to 0, I less than 1000, I plus, and within that the inner loop, the range of the inner loop is from 1 to 1000, but it will increase j is equal to j into 2. So we can say this is what? It takes n time, and here it takes log n time. So as a whole, we can say the time complexity of that loop is order of n log n. Order of n log n. So is it clear? So basically, our objective is to check how many times the statements will iterate. How many times the statements will iterate. In case of linear time, maximum n times the statement will iterate. That's why this is order of n, or we can say big O of n. For logarithmic loops, the number of iteration will be what? Log n. Log n times the block of statement will iterate. That's why it was order of log n. And here, this is what? N square times the block will execute or iterates. That's why this is order of n square. And here, this is n log n time the statement blocks will execute or iterates. That's why we can say this is order of n log n. Now, any question? Is this clear?
Yes, sir.
Yes, sir.
Okay. Next, I have two pseudocode, one for matrix addition and one for matrix multiplication. Just write the simple pseudocode. The first one is for matrix addition. You have to read first matrix A, then you have to read matrix B. After that, you have to compute the addition, and then you have to display the result. So here, for this part, what will be the time complexity? I think all of you know. It will be what? Anybody? It will be what?
So n square.
Exactly. Similarly, for reading of matrix B, again this is n square. Now for computation, for addition, again we have to use a nested loop. That means here again n square. And for display, again n square. So I think all of you know how to write the C code of matrix addition or multiplication. I assume that you know that. I assume you know how to write matrix addition or matrix multiplication in any platform. So whatever be the platform, first you have to read the matrix A, that takes n square times. Next you have to read the matrix B, again it takes n square time. After reading A and B, you have to add those matrices and store the result in C matrix. That also takes n square time. And after computation, it also algorithm. It takes two input, that is matrix A and matrix B. After that, it processes those inputs. So this is the process part. And after that, you have to produce some output. So for producing output, again it takes order of n square. So as a whole here, n square plus n square plus n square plus n square, it means 4n square. But the thing is that it may be n square or 4n square or 100n square. or 1 million n square, asymptotically all are same. That's why we can say the time complexity is order of n square. Is this clear? It may be 4n square, it may be 5n square, it may be 10n square. This is what? It's a constant. It's a constant. So some constant into n square. This constant may be 1000, maybe 1 million. But it does not make any sense. Asymptotically, 4n square, 1 million n square, 10,000 n square, and n square is same. That means the time complexity of matrix addition is basically depend on n with what? Linear or quadratic. It depends on quadratic of n, that means n square. Similarly, for matrix multiplication, again you have to read one matrix. It takes n square time. Here again you have to read another matrix, takes n square times. Now the interesting points here. There are 3 loops one by one. The loop J is within the I loop. The loop K is within the J. That means it also within the I loop. So here for executing Cij, that is Cij plus Aik into Bkj, it takes n cube time. Is it clear why this is n cube? Because when I is equals to 0, j is equals to 0, this loop will execute n times. When I is 0, j1, again it will execute n times. When I is 0, j2, again it will execute n times. So that's why here this part takes n cube times. And this part for displaying the output, again it takes n square times. That means as a whole we can write, what we can write? N cube plus 1, 2, 3, 3n square. N cube plus 3n square. Now for higher and higher values of n, we can ignore that part. So you have to consider only the highest part, that is n cube part. That's why here the time complexity is n cube. Is it clear why this is n cube? Because we have an expression that is n cube plus 3n square. But we have to consider only the highest values of n. Here n cube is the highest one. N cube is the highest one. For any positive values of n, any higher positive values of n, you can ignore that part. That's why though the expression is n cube plus 3n square, asymptotically we can say the time complexity is order of n cube. The time complexity is order of n cube. I am giving you another example. Suppose you have expression like this: n square plus n log n plus n. Now say anyone, what will be the time complexity? Suppose I have calculating each part of the program. The first part takes n square, second part takes n log n, third part takes n, only n. That asymptotically the time complexity will be only order of n square, because this is the larger part than this and this. Suppose for a linear loop, we have seen the time complexity is n. Now if I have a loop, say for I is equals to 0, okay, then I less than n by 2. then I plus plus, I plus plus. Say some statements are there, some statements are there. So what will be the time complexity? How many times?
Order.
How many times this statement will execute? The statements will execute maximum n by 2 times. Though asymptotically n by 2 and n is same. Asymptotically n by 2 and n is same. Because the classifications is what? First constant time, then logarithm, that is log n. After that n log n, after that linear, that is a, then n log n, then n square, then n cube, then n to the power 4, which is less than n to the power 5, which is less than n to the power 6, dot 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 dot, which is less than n to the power n or something. Okay, so if the loop is ranges from 0 to n by 2, then also we have to say the time complexity of that algorithm is order of n, not order of n by 2, because asymptotically order of n by 2 is same. Asymptotically 4n square, 100n square, and 4n square, 100n square, and only n square is same. But if you have, say, the time complexity of different parts of the algorithm is n square, some n cube, some n is there, always you have to take the maximum one. That's why in matrix multiplication, the time complexity is order of n cube. Though the reading matrix A, it takes order of n square, read the matrix B, it takes order of n square, and display is again takes order of n square. But as a whole, the time complexity of matrix multiplication is order of n cube. That means if the problem is written in iterative way, so already we know there are two types of function. One is iterative function, another one is recursive function. So if the problem is written in iterative way, we can identify, we can determine the time complexity by how many times the statement blocks will iterate. Based on the iteration of the statement block, we can determine the time complexity. If the problem is written in iterative way, if the program is written in iterative way. Now, next one, which is very, very important. If the problem is written in recursive way, say here I am giving you one example. I have written two functions of a same problem factorial. So factorial in first one I have written in iterative way. I is equals to 1, I less than n, I plus plus, fact is equals to fact into I. So how many times it will iterate? The block fact into is equals to fact into I will iterate n times. That's why we can say the time complexity of factorial is order of n, or we can say big O of n. I think now it's clear. Now the question is, if the function is written in recursive way, there is no such loop. So how we can determine the time complexity? So for a problem that's written in recursive way, first we have to determine the mathematical model for that. That is known as recurrence relation. So for each and every function written in recursive way, you have to first determine the recurrence relation. So how we can write the recurrence relation? I will discuss. Say factorial n. Now here this is the base condition, or we can say this is the terminating condition, and here the function calls itself with the smaller value. So what is recursive function? A function calls itself with some smaller value and always converts to the base condition or terminating condition is known as recursion or recursive function. So this is your base condition, and here this is the recursive function, because the function factorial calls itself with some lesser value. So T of n means what? Time to execute. T of n means what? Time to execute the problem of size n. Time to execute. Time to execute the problem of size n. Now, if the size of the problem is either 0 or 1, that means if n is equals to 0, what will be the factorial value? The factorial is 1. If n is 1, then the factorial of 1 is also 1. So we can take this 2 as the base condition. Now, for that, it takes a constant time. So why constant time? It's clear. Why constant time? It's clear. Because this is where n is equals to either 0 or 1. So if n is equals to 1, it returns 1. If n is equals to 0, it returns 1. That means the time is constant. So that's why I have written T of n is equals to a, where a is constant, when n is equals to 0 or 1. Now the next part. In next part, it basically returns n into fact of n minus 1. So factorial 0 or factorial 1, there is only one comparison. That's why it takes a unit time. That means the first one. And for second one, for factorial n, where n is greater than 1, factorial n, where n is greater than 1, there is a one comparison. What kind of comparison? You have to check whether the value of n is either 0 or 1. Suppose your n is 5. Suppose your n is 5. That means this is not 0 as well as not 1. This is one comparison. One multiplication is there. One multiplication is there. As well as one subtraction. Subtraction takes constant time. Multiplication takes constant time. Addition takes constant time. So these are all constant time, along with the time that takes to execute factorial of n minus 1. So that's why I have written T of n is equals to T of n minus 1 plus b. Here this b is constant for one comparison, one multiplication, and one subtraction. One multiplication, one subtraction, and one comparison. That's why this is b. Along with what? Along with what? Along with factorial n cos factorial n minus 1. So if T of n means time to execute the problem of size n, then T of n minus 1 means what? Time to execute the problem of size n minus 1. So that's why I have written T of n is equals to T of n minus 1 plus b. Now just derive it. So from here, we can write T of n is equals to T of n minus 2 plus 2b. Just substitute T of n minus 1. Say T of n is equals to, we know T of n minus 1, T of n minus 1 plus b. Now what is T of n minus b? Now what is T of n minus 2? That is something like T of n minus 2 plus some constant b. So this b and that b, it will be 2b. Is this clear? Is this clear? Anybody? Hello? Is this clear?
Not getting clear.
Yes, sir. Yeah.
No, sir.
No, sir.
Which one?
We're
Which
not
one?
getting that
Okay, okay.
additional.
Which one? Let's
Sir,
again.
sir, you can speak
I am
faster.
explaining. Again, I am explaining. T of n is equals to T of n minus 1 plus b. This is the recurrence relation. Because this part takes one comparison, one multiplication, one subtraction, as well as it calls factorial again with the value n minus 1. So T of n means what? Time to execute the problem of size n. So T of n factorial n calls factorial n minus 1. That means T of n minus 1 is what? Time to execute the problem of size n minus 1. Now, T of n minus 1 calls T of n minus 2, fact n minus 1 calls fact n minus 3. That means what? T of n minus 2, T of n minus 3 is what? Time to execute the problem of size n minus 3. That means our n, the value of n is decreasing gradually. Initially it was n, after that n minus 1, then n minus 2, then n minus 3, n minus 4, and so on. So when this is n minus 1, that means when we come to n is equals to 1, that means if our initial n is 5, then fact 5 call fact 4, that means n is equals to 4. After that, fact 4 call fact 3, that means n is equals to 3. Then fact 3 call what? Fact 2 call fact 1. So when n is equals to 1, when if n is equals to 1, it is T of n minus 1 plus how many b's are there? First 1b, then 2b, 3b, n minus 1 b's is there. So it will be what? T of n is equals to n minus n plus 1, that is T of 1, plus n minus 1b. So we know T of 1, that is constant. Here this b is also constant. And here along with b, we have n minus 1. So asymptotically, n minus 1, n minus 2, n minus 3, n by 2, all are same. That's why we can say the time complexity is order of n. That's why we can say the time complexity is order of n. So for each and every recursive function, first you have to write the recurrence relation. This recurrence relation belongs to the base condition or terminal condition. Every recursive function, there must be a base condition. Here the base condition is if the value of n is either 0 or 1, it takes constant time. But if the value of n is not 0 or 1, that means something which is greater than 1. So on that time, you have to call the function again with the smaller value. So that's why if n calls f4, f4 calls f3, f3 calls f2, f2 calls f1. Here fn calls fn minus 1 with some constant. Fn minus 1 calls fn minus 2 with some constant. That's why I have written T of n minus 2 plus 2b. Here this calls n minus 3 plus some b. N minus 3 plus some b. That's why this is n minus 3 plus 3b. And then it will be n minus 4 plus 4b. That means the size of the input is decreasing in nature. Initially it was 4 or initially it was n. After that n minus 1, n minus 2, n minus 3, n minus 4, n minus 1. That means T of 1. So T of 1 is what? It's a base condition. That's why I have put A instead of T of 1 and n minus 1b. So 1b, 2b, 3b, 4b, n minus 1b. So this is constant, that also constant, and n minus 1 is asymptotically same as order of n. That's why we can say the time complexity of factorial is order of n. So using recursive way as well as using recursive iterative way, here I have explained how the time complexity can be calculated, and always the time complexity is a function of your input size. Every time the time complexity is the function of input type. Sometimes it may be constant, or sometimes it may be linear, that is order of n, sometimes order of n square, sometimes order of log n, or n log n, or n cube, and so on. Okay.
Sir,
Okay, okay, yes.
okay.
Okay. Just okay. Have a good day. Okay. Okay, thank you. Just send
Sir,
the
in
mail.
next class, please explain the last part. Sir, in next class, please explain the last part.
I'm not listening. Please.
In next class, please explain the last part only.
Yes, sir. The
Okay,
recursive one next class, please repeat.
Okay, I will explain again. Okay, no issue. Okay, no
Okay, sir.
issue.
Thank you, sir. Thanks a lot.
Okay.
Thank you, sir. Thank you.
Sir.
Can Mamla.